Good morning all. Today I'm going to build an ammeter using an OLED, this little 128 by 32, and a current sensor, the INA219. Now I've already done a couple of videos, one on the INA219 sensor, so I'll put a card up there for that, and also another card for the OLED, which I also did using the U8G2 library. This 128 by 32 OLED, another card up there for that one. Now in those two videos I used an Arduino Uno or something very similar, but this time I'm going to use the Arduino Pro Mini, and it's this particular type with the two rows of pins down one side, because if you flip it over, the I2C, which is VCC ground A4 and A5, roughly lines up with the pins on the current sensor and also the pins on the OLED. So let's have a closer look at that. Now, firstly, you can remember that A4 is SDA because D is the fourth letter of the alphabet. That doesn't work with A5 and SCL, but just remember the D bit. So here we have VCC ground, ground VCC, so those will have to be flipped round. SCL, SDA, we've got SDA, SCL, those two will have to be flipped round. And for the OLED sitting on top of this board, ground VCC, they're in the correct positions, ground VCC. And again, SCL and SDA will have to be flipped round. So I'm going to take the pins out of the OLED display, take the pins out of the current sensor, and just use pieces of wire to make a sandwich of these three boards. So the first thing I need to do is to take the plastic piece off this four-way pin adapter, because then when that plastic piece is off, I can just heat up these pins, give it a whack, and they should drop out onto the bench. Right, let's see if this is going to work. Just heat up these pins one at a time and flick them out. Yeah, that works well. That one didn't. Try ground. Okay, those two are going to need a little more encouragement. Right, I'm going to use some of this 24 SWG tinned copper wire as my little link wires. So cut off some pieces of this. That's probably a bit too long really, but... Right, 4 wires for wiring the OLED onto the Pro Mini. Right, let's solder those onto the front of the board. Ground, VCC, SCL, SDA. Okay, so this is how I'm going to do it. We've got ground, VCC, and then SCL and SDA cross over. Now at the moment those wires are touching, but once I've pushed this right down as far as I can reasonably get it, then I'll force a screwdriver in there and just push those two wires apart so they're no longer touching. I'm just wondering whether to put a bit of sticky foam pad in there. Perhaps I'll do that after I've soldered it. Right, let's solder these on here, but I'm not going to cut these off because these carry on and will go through the current sensor board, the INA219. So let's just get those 4 soldered. And try and remember not to cut them off. Of course I can snip these off on the top of the OLED board, because I don't want these sticking out bits here. So let's trim those. Whoops, that one shot across the room. Yeah, so that's fine. Then I just need to separate those two. Now which are they? They're SCL and SDA, so it wouldn't blow up if those were shorted, but it certainly wouldn't work either. So I've put a screwdriver between these two wires which are crossed over, and I think you can just about see that they are now separated, so they're not going to short out. And this is quite rigid, but I can put a little foam packer in there later. But now let's get the current sensor board on. Now once again I need to get all these pins out. So I've got to heat these up and give them a whack. There's 1, 2, there's 6 of these, although 2 of them are the V in minus and V in plus. but I'm probably going to wire that into the terminal block. There, that's 5 of 6 out. And that's it, done. So there are two crossovers here, VCC and ground are crossed over, SCL and SDA are crossed over, so that needs to fit on there like that. I've got to push that as far down as I can get it, and then ease apart the crossovers so that they're not shorting. Right, let's solder these 4 wires, and then that's all the interconnections between the current sensor, the Arduino Pro Mini, and the little OLED. Good, let's ease those wires apart. Right, I need a 6-pin right-angled header for programming the Arduino. I probably should have thought of that earlier, so I've had to bend the OLED up a bit, but that can fit in there. So I'm just going to push that down onto the blue tack and start soldering that on. Right, here's my sandwich of OLED, Arduino Pro Mini and the current sensor, with the wires all bent and twisted to get the pins all going to the right place. Got my programming header here, got a CH340 programmer here. I should check, I suppose, that this is a 5-volt Pro Mini. I'm also going to need a power input, so I'm going to connect that to RAW there, RAW, and ground, which is sat right next to it. I'll probably use a 2-pin JST for that, and then I can use one of my 9-volt PP3 battery holders. Right, here's my 9-volt battery box, and I've plugged it into a JST 2-pin socket, so I've got to get the red to raw, so it's going to have to go that way. I think it's going to have to come in from the side because I can't really put it on the top now because the OLED's not really in the right place. I suppose I could have moved the OLED further towards me, but anyway, I'll bend the pins on this JST and have it coming out the side for the moment because this is only a prototype unit. Right, my power socket is soldered onto raw and ground, but I don't need power for this yet, so that can come out because I'm going to power it from the CH340 USB to serial adapter, because I just want to get a program in here and make sure that the OLED's running, so I'll just put my OLED program in there now. Right, I couldn't find a USB extension lead, so what I've done is I've swapped out this, CH340 module with a Type A USB for this little CP2102 module, which has a standard micro B on there, so that's going to be a bit easier to connect up. Let's hook that up and load in the OLED program. Right, here's my OLED 128 by 32 sketch. We set the OLED up as the Univision hardware I2C, and this is a reset thing, I think. This is all detailed in the video about the 128/32 OLED that I did before. Now what this does is it just prints millis, so if I upload this to, or download it to the Pro Mini Arduino, then we should just simply get a millis count on the display 5 times a second. And yeah, that's working. That went via the CP2102 into the Pro Mini, and we have indeed got the millis count coming up on the OLED there, so that's good. So now what I need to do is get the program, which I think is Adafruit, an Adafruit example for the INA219 current sensor, munge that together with the OLED code and come up with, well, an ammeter. Right, this is the Adafruit INA219 code, and I don't need wire because I've already got wire in the other program. I do need this include, the Adafruit. I also need this is that the constructor call? Yes, I think that's the constructor call, so I'll take those 2 lines. Right, in setup for the Adafruit, I don't need the serial begin because I'm not going back over serial now. I do need this one, INA219 begin, so let's copy that, switch to my new program, which I've called OLED INA219, and that will go in setup. So shall I put the OLED first? The current sensor first. Yes, that's what I've done on the line above. So let's put a return in there. Paste that in. So we've got an INA219 begin and a U8G2 begin. Let's just tidy that up a little bit. Right, in the loop, I don't need the shunt voltage or the bus voltage or any of that stuff. All I need is this, float current in milliamps. I'll need this one, current milliamps is INA219 get current milliamps. And then I don't really need all this serial print stuff, so looks pretty straightforward. Let's copy that. Right, so that's my program complete. Two constructor calls, INA219 and U8G2, which is the display. Begin both of those objects, and we have a float, which is the current in milliamps. It gets that from the INA219 and then prints it on the display in milliamps. So let's compile and upload that. And the result is this, and there is a bit of an offset on here, and at first I thought, well, that's a massive offset, but of course this isn't amps, this is milliamps. So we're getting sort of up to 1 milliamp of offset on this current sensor. I can't remember whether the sensor has an option for removing that, but it doesn't really matter at the moment. Right, this lamp should draw about 100 milliamps, a bit less because it's 100 milliamps at 12 volts. I'm going to put 9 volts on there. And we have 91 milliamps. So my little ammeter is working. Now, I need to power this really off, not the USB 5 volts, but my 9 volt input here, my raw input, which goes through the regulator on the Pro Mini, the voltage regulator, which is there somewhere. So let's power this now from another 9 volt battery. And there it is, powered by the 9 volt battery, measuring the current flowing through this circuit, another 9 volt battery and a bulb. Now that's showing 87 milliamps. This should be able to read bidirectional current, so I should be able to flip these two wires over and get a negative reading. Let's try that. I'll do this on camera if I can get the camera. No, camera can't see that right, so let's come around there. Let's take these wires out. That should go to 0 or thereabouts. Yeah, swap these over and poke them back in. And perhaps I will have to do them up. But anyway, there is the negative reading. So minus 89 milliamps with the current flowing the other way. So this can read current flowing in either direction. Gives you a plus or a minus indication. So that works. I think that's enough for this particular project. Now ultimately what I want this for is to measure the current flowing into and out of lithium 18650 cells, which I'm going to put in this holder. Initially I can have just one of these ammeters measuring the current flowing from one lithium cell to the other, or back the other way, depending on which one's more charged. Later I want to put two of these ammeters on each cell, and then when charging the cells we can see the difference in current going into those cells depending on the different capacities of the cells. But that can come another time for another project. And I'll put the Arduino code that I've written today for this onto Hastebin so that you can copy that and have a play with it if you want. But for the moment, that's it. Cheerio.